Hello, my name is Jonathan, a biologist and ecologist from Brazil. I'll be presenting today the topic of a master's thesis regarding purple martins and mercury contamination in the Amazon. Mercury is a heavy metal that has no safe levels of consumption. It can lead to several physiological problems including DNA mutations, hormonal disruption, neuropathologies, and behavior changes, among others. In fact, mercury can affect virtually any tissue or organ, and its effects are only limited to the concentration, ranging from minor effects to the death of the organism. Some regions of the world have naturally high levels of environmental mercury. One of these regions is the Amazon basin, that receives high concentrations of elemental mercury from mercury deposits in the origin of its rivers at the Andes mountain range. And that brings us to the purple martins. Some populations of purple martins have been seeing declines over the past 5 decades. Most of the decline is seen in the states from eastern regions of North America, where the subspecies Prognis subsubs occurs. What these birds have in common is that they all migrate to the Amazon basin. These birds, coming from many different states in eastern North America, all share a similar location in the Amazon basin, where they form roosts with millions of individuals. Therefore, we believe that the reason might be linked to that region. However, since they have always migrated to the Amazon basin, and this region has always had high natural mercury contamination, this does not explain the decline in just the last 5 decades. More recent events in the region might be to blame. In fact, one particular change in the same time frame might be the missing link. The increase of hydroelectric dams in the region over the past 5 decades, the same period we start seeing the decline rates, might be a contributing factor. The problem with hydroelectric dams is that they decrease the water flow, allowing for particles in suspension to sediment. And that includes elemental mercury that encounters bacteria at the substrate. Bacteria at the substrate can methylate mercury, creating an organic form of mercury that has a higher affinity to organic tissues and can be, therefore, much more toxic. Many studies have pointed to an increase in organic mercury in rivers after the construction of hydroelectric dams in the same basins. After being methylated, mercury can easily accumulate in organic tissues and travel up the food chain, becoming progressively more concentrated in higher trophic levels. Insectivorous birds, like purple martins, are known to accumulate methyl mercury at greater concentrations than herbivorous birds. Because of this, we decided to evaluate mercury content in purple martins and assess correlations with body condition and hormonal concentrations. Using feathers that were grown in the Amazon basin, we were able to measure the concentration of mercury and hormones while the birds were present in that region. Feathers are a great source of information for circulating compounds. They are connected to the bloodstream while they are growing and can accumulate contaminants and hormones. Furthermore, once they finish growing, feathers cease any connection to the bloodstream and stop receiving any circulating compounds. Therefore, feathers that grew in the Amazon basin only show mercury and hormonal levels accumulated while the bird was in the Amazon basin. However, we did not find any correlation between mercury concentration and hormonal concentration, which is not to say mercury did not have an effect on the hormones, but if it did, we were not able to measure it on the time frame of the feather growth. Or maybe with a greater sample size, we would be able to see a clearer correlation. That's why we are continuing this project with more locations and samples. Nevertheless, since we sampled the birds after they migrated, we are also able to measure the bird's mass and fat score, which is a measurement of fat content in birds. Both mass and fat scores showed a negative correlation with mercury concentration. That is, birds with higher mercury concentration showed a lower fat score and mass when they returned from migration. Fat content is particularly important since migrating birds require large deposits of fat as the sole energy source for the duration of the migration life, which could also be the reason they had lower mass. Both mass and fat content are frequently shown to decrease with mercury contamination in other species, which is concerning if the concentration of methylated mercury increase in the Amazon. In fact, there are plans to build hundreds of hydroelectric dams in the next few decades in the region, further changing the landscape, water flow, and allowing for higher methylation of mercury. Besides, the presence of artisanal gold mining in the region increases the concentration of elemental mercury above that of the naturally high levels. If the correlation found is a result of real effects of mercury in reducing fat reserves, this can result in the death of birds that lack sufficient energy for the migration. However, we cannot establish that without first measuring more birds from these and other locations to compare the results. Our work so far cannot conclude mercury contamination is the result for the decline. In fact, it's unlikely there's just one reason. However, the effects that mercury can have are concerning for a species that is currently in decline. So, even if it's not the reason for the decline, it can accentuate the problem. That is why this work continues. The results of this research presented here will be published soon, but we have already started further study including a much higher sample size, with birds from more locations. And some of you might be able to help us. This project was only possible due to our collaboration with the PMCA and volunteers that collected the feathers and data from purple martins at their properties. The Purple Martin Conservation Agency has been receiving and coordinating the data that citizen scientists have provided over many years, allowing many conservation projects like this one that relies on this data. So if you have purple martins visiting your property and you have easy access to them, you might be able to help us gather samples. We need feather samples along with any information that you might have on these birds, such as age, sex, and measurements. Particularly, we are in need of samples from the western coast, but we welcome samples from all regions. So if you think you can help us, please contact Joe Silgrist from the PNCA and he'll be able to tell you how you can help. And with that, I thank you for listening to my presentation and I welcome any questions.
All right, Jonathan, thank you so much. Let me find you in the chat to unmute you. And while we're waiting for some questions to pop in here, just to follow up on Jonathan's last comments there, just in case folks are confused. Removing feathers from purple martins and possessing feathers is something that only licensed bird banders can do. So if you're interested in helping and are a bird bander, then or you know a bird bander that might be willing to come and sample your birds, then reach out to us. And furthermore, I know we had a lot of participants in feather sampling already, and you may be looking at the map that Jonathan showed there from that study and saying, wait, it's only 3 different places that use feathers from. This is a preliminary study, almost like a proof of concept, because it costs a lot of money to sample feathers. So the goal is to use this to then state a case for a larger grant that then allows us to use more feathers from all over the place and sample for more things. All right. Jonathan, did I get you unmuted? Are you here?
I think so, yeah.
Okay, perfect. You think so? I think I'm here. Jason asks, are there other environmental contaminants you're concerned about in the Amazon?
I would say it depends on the region, because some regions of the Amazon have some pesticides, for instance. And I'm not sure about other chemical elements that are present in the Amazon, but I think there is a project that is starting with other chemicals, and we might be able to see some other important contaminants. Some other contaminants that are common are arsenic and copper. Those occurs naturally in some regions, and it might be the case for the Amazon, but I don't know if that's a fact or not.
Yeah, so the PMCA and our partners in this research are kind of getting ready to apply for a sizable grant to expand to a lot of different pesticides to really look, because we have this wonderful treasure trove of feathers thanks to volunteers, banders, and folks that have sent us in samples, and we're really going to use that as an opportunity to really see what all purple martins are exposed to in Brazil. Jonathan, I had a question. You mentioned how hydroelectric dams increase the level of toxic mercury in the system. But you spoke of naturally occurring mercury mostly. I've heard a lot about illegal gold mining and how mercury is used in that. Could you speak a little bit about what that input of mercury might be, and if it's a significant contributor?
I think it's hard to say in the amount, how much mercury is being deposited as legal gold mining, because we don't keep track of them. We have some estimates, we have some studies, but for instance, just last week, we saw a news from New York Times. Done they've done a pretty good article on some illegal planes and that are being flying in the Amazon and collecting and using the rivers for gold mining. So they do use a lot of mercury for that, and we don't know how much of that is being deposited. How much of the mercury that we see in the Amazon is from illegal gold mining, but it's definitely a problem, especially in recent years, because it seems that it's increasing a lot, and
Yeah.
that's really concerning for not just for purple martins, but for a lot of species, including human populations that live on the riverside and fish and eat a lot of the fishes that are growing there. So those populations, we know they have a higher mercury content. Even the human populations, they have higher mercury content than the average. So
Yeah,
it's a
there's
problem.
no amount of mercury is healthy. Any mercury is toxic, right? Jonathan, I had another question. Do you think so? So the samples that you analyzed are only from the birds that survived to make it back to the breeding habitat. So do you think that there may be other birds that didn't make it?
Well, we know some birds don't make it, whether it's because of mercury or not. We cannot really say with this study, and that's why we are continuing the study with some other feathers, including feathers from birds captured in the Amazon itself. This work will be done by Clarissa. She's starting her PhD in this research topic, so she's basically continuing and expanding on my project with the other feathers that you also mentioned from many places in North America as well. So
Yes.
we want to find out if there are birds that are not being contaminated by higher levels of mercury that are not surviving the migration back. And this
Yeah.
might be one reason, because if the correlation is in fact a causation, if the correlation that we see with the decrease in mass and fat score, then it could be problematic for a bird that requires fat reserves for the migration.
Yeah. So it could very well be that there are birds that are much more poisoned by mercury that are dying because they don't have enough fat reserves to make it back. And we do have feather samples that we've collected at the roost in Brazil, among other places. It's just we're running into challenges in getting those feathers here to North America to sample at Northern Arizona University. Erica says, would be great to have feathers from chicks as well, as those are grown in the Northern Hemisphere. Very useful to compare with feathers from adults that are grown in the Amazon. Do you care? Jonathan, could you just comment on why that might be important?
So if we know, because we capture the feathers because they are grown here in Brazil, so we would have an idea of the contamination that is occur in Brazil. But it's also important to compare with the contamination that might be occur in North America, because we don't know if that's as great. We don't expect it to be as great as the contamination here, but it might be one metric for us to compare if it's indeed a problem caused by the contamination here and not just continuous contamination that the birds might be facing.
Absolutely. Creating a baseline. Absolutely,
Yeah,
Barbara.
pretty much.
All right. Well, Jonathan, thank you so much for the important research you did. Thank you for sharing it with us here. And I know you're getting ready to go off to a PhD program. So good luck wherever you end up going. And hopefully it still involves looking at purple martins.
I probably will be, as we are talking with David Luther, and he's involved in this project, or he will be involved in this project. So I'll probably be sticking around with you guys for the next 4 years at least.
Awesome. It's been a pleasure working with you, Jonathan. Thank you so much for being here today.